Hey, welcome everyone, and welcome to Strange Danger, your JavaScript attack surface just get bigger. I'm Sana Moiset. I'm a senior security advocate here at Sneak, and I'm going to be taking you through today's session. So welcome, and thank you for joining this session. And yeah, let's start. Let's share the screen. Cool. So what are we going to talk about today? So first of all, we're going to check the current state of open source, and we're going to see what are the hot topics. We're going to have also a look at the iceberg. It might be like this little emoji thinking, what is the iceberg? Then we're going to do a few hacking, and we're going to have the help of Patch, which is also here today with us, to help us fix and remediate to all of these vulnerabilities. And along the side, I'll give you a little bit of learnings and some tips for defense in depth. So let's start with the current state of open source security. So organizations of all sizes are heavily reliant on software. We know that much of that software supply chain consists of a lot of open source components. And thus the open source ecosystem has cybersecurity implication. And because it's an attractive entry point for people and organizations interested in theft, disruption, or exploiting for economic or political gain. Thus, the consequence is that the attack surface is changing. And from those in traditional cybersecurity, this also changed the threat models. And also the defects in small libraries can cause systemic risks. And we've seen that with last year, the incident with Log4Shell. Cool, so vulnerabilities can originate for something as simple as a configuration error or using a software component that contains a known vulnerability, which is why maintaining and improving application security is so important for businesses. So one recent study revealed that out of 85,000 applications that were analyzed, 83% contain at least one security flaw. And of these, 20% has a severe vulnerability. While we know that not all of this vulnerability necessarily presents a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate softwares. And we have organizations such as OWASP, which is the Open Web App Security Project, that track vulnerabilities found and provide a list that developer and security teams can use as a starting point for their application security program. And the most recent OWASP Top 10 list was released in 2021 and included vulnerabilities like broken access control, injection attacks, security misconfigurations, and more. So let's have a look at some of the open source software attacks. The first one is typo squatting attacks. So typo squatting attacks takes place when bad actors push malicious packages to registry with the hope of tricking users into installing them. This is really similar to website phishing attacks that exploit typos made by individuals who may accidentally type in the wrong address. Here we have an example with the package React with a typo. And in that case, you will not install React, but a malicious package that has a completely different end goal. Another example is the malicious packages which inject malicious code into a software product in order to compromise dependent systems further down the chain. So in this example, we're having a package called Fall Guys, and usually the malicious actor will try to surf on trends. So in that case, he is using a game that has been quite popular during the pandemic, and user might think that downloading this package will will give them an advantage in the game. So you can do like in the game probably like changing the cosmetics or getting more ammunition or those kind of things. But for this specific package, Fall Guys was a malicious package, obviously, and that contained malicious code that attempt to read local sensitive files and exfiltrate information through a Discord webhook. So the entry point was a Discord webhook. And this piece of code was intended to access specific paths available on the Windows system. So it was looking at the local storage. And one last example is compromising maintainers, where malicious actors will use engineering methods to gain access to open source projects. So here we have an instance in the event stream package where the malicious code actor did social engineer the maintainer. So what he did, he actually went through all the issues, and he wanted to have an issue where he could potentially push his payload. So first of all, he pushed some cosmetics changes at first to build up the trust with the maintainer. So he changed some README file, pushed some CSS fixes. And once he got more permission, he pushed his malicious payload into the code base. And in that specific case, it was targeting a Bitcoin wallet. So his modus operandi was interesting in going through all of the issues and see if he can contribute, be trusted, and then push his code. This is known as a supply chain attack, and it's also called third-party attack. It occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. So it doesn't affect only JavaScript packages. This is also an issue for all ecosystem. And we had a recent example last year with Log4Shell within the Java community with a vulnerability in the open source Apache Log4 logging library, where we had one of the Log4j exploits that would allow remote code execution on the servers, running vulnerable applications without requiring authentication. So that has earned the vulnerability a severity rating of 10 on the CVSS scales, which is the common vulnerability scoring system. And we know that Log4j is used in many commercial applications, and organizations might be vulnerable without knowing that they are actually using the logging library. So supply chain attacks are attractive to hackers because when commonly used software or packages are compromised, the attackers could potentially gain access to all of the enterprise that use that software. So let's try to understand how this is possible. And let's say hi to the iceberg. If you're confused by that statement, let me explain it to you. So this is the iceberg. And you might still ask, that's cool, Sonia, that's an iceberg. What about it? So let's start with the tip of the iceberg. Our starting point is our code. This is the proprietary code that we write in an organization. Does this bring security vulnerability into our code base? Maybe. So in that example, what we have a function signature of an Express application with a function which has a request, a response, and a next callback. So it's trying to call the user table or collection, which means that there's a database behind the scene. And it's trying to do a login, looking for a username and password. So what are the vulnerabilities here? What can go wrong? Here we have a good example of Nosql Injections, so it's database injection. So applications built with Express will have a body parser to parse the JSON object, and it takes whatever you send to and convert it to a JavaScript object. If the request has a username and a password, this is going to be part of the JavaScript object. So if you're using MongoDB and add the $sign greater than as a key and an empty string and a value, the JavaScript object will tell MongoDB to do a greater than match to filter all the results. And basically, when you send the request with admin, you'll be logged in as an admin performing a NoSQL injection with that piece of code. So this shows the importance of sanitizing inputs and to handle this as soon as possible before it's stored in your database. So we started with our code where potentially we can have security vulnerabilities. This is a piece of code to import a dependency, which is a nice segue to the layer below the application code on the iceberg. The second layer is the open source code. So if we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we know that we don't want to reinvent the wheel. And this is totally understandable. Why would we waste some time to rewrite something that might probably exist as a package in our ecosystem? So that's what we have here with the Mark package and a lot of few other packages around that. But we're now bringing several packages into our code base, increasing the attack surface and introducing new risks. So are we aware of all the packages that we have? Do we know all the dependencies and sub-dependencies? Do we have a good understanding of indirect and transitive dependencies? Do you have tools that help you having that level of understanding and visibility? And also, what are the risks when you bring a dependency into your code base? I know, that's a lot of questions, but let's see some numbers around that. So we can see that the average number of outstanding and critical vulnerabilities in an application is around 5. And this obviously depends on the programming language. Also, for the average dependencies per project, we're having an average of 80 top-level dependencies. Also, this is based on your programming language. But the most, I'd say the most scary one is the last one. It takes almost 100 days in average to fix a vulnerability. So enough chatting for now, and let's move on to hacking an app with Patch. Patch is going to help us on that, and understand more about how dependencies can impact your application and introduce vulnerabilities that you were not aware of. So I'll be using a few applications that you can find on the Sneak Lab GitHub repositories. The first one I'm going to use is the Node.js goof, and this is what it looks like. This is basically a patch to-do lists, as you can see. And you might think how you could tamper potentially with this application. And I'm seeing that Micah has joined. I'm going to ask Micah, there's potentially 3 vulnerabilities that I can demo today. So there's a path traversal, there's a store XSS, and there's a prototype pollution. Which one would you like to see first?
Oh boy, they're all so juicy. What should we see first? How about path traversal? My favorite.
Okay, yeah, let's do path traversal. So path traversal starts at the URL. So here, obviously, I'm serving the application locally on my machine. So you could imagine if you're serving your application somewhere else. But let's have a look at this this URL. So we're going to start with just adding the public folder at the end. And oh, interesting. I can have access to a few information here. So I have the CSS, the JavaScript, okay, robots. That's interesting. That's probably not enough. So I'm going to put my hacker's hat on and try to tamper with this URL and see if I can traverse the directories to try to find sensitive information like credential or password. So usually when you want to traverse, do that exploit, you should you're using the // commands to check the parent directory of the current directory you're in. And in that case, it's not working. Interesting. So I see there's some sort of sanitization going on, which is good news. But I haven't said my last word. So let's try with URL encoding. So basically, I'll be using the %2e and %2f as URL encoding. And oh, this is working. So let me just get a step back and explain what is URL encoding. So if I'm zooming here. So basically, the URL encoding is replacing unsafe ASCII characters with a % followed by 2 hexadecimal digits. So in our case, we want to actually encode the // So this is why I'm using the %2e for the dots and the %2f for the slash. Cool. So surprise, I have access to more information here. Let me see. Deploying the application on the Heroku. Okay. Have the Dockerfile, more information. This is giving a lot of info for the potential attacker. The Docker compose YAML file. Oh, interesting. There's like some passwords here. Cool. Okay, so you can see that the attacker might have access to a lot more that he or she should have. So let me try to continue traversing the directory and see what I can have access to. So here, obviously, I'm going up on my local machine, but you can imagine if you're hosting on a server, you have access to all the folders. And I'm going to go up one last time. And oh, have the etc, the binaries, and more interesting folders. So yeah, I'm not going to click on it because I don't want to reveal any sensitive info, but you get the gist of it. So I'm just going to go back to the front page. And we're going to have a look at the code and see what is going on here. So to serve the static files in this application, we're using a package called st. So here you can see, just going to zoom this one closer. So yeah, I'm importing it here. And I'm instantiating the package here. So you can see that it was serving with public. So this is why we had access to public. But apparently, the st package has a few vulnerabilities. So let's ask patch help on that. So how we can do this? So basically, I'm going to use the marketplace here. I'm using VS Studio Code, by the way. And if I type sneak here, because the first one to come is the to appear is the sneak security code and open source dependency check. So if you install this one, you need to reload your ID to take into account, and then you'll have the little patch icon here. And the first time you won't see this, you'll see the little patch icon here. They'll ask you to authenticate with your, you can do this with your free Snyk accounts. And then when you can run the scan. Cool. So let's see in the package JSON. So patch is going to go through all these dependencies and let you know if there's any vulnerabilities. And there is here on the SD package. So if I hover over the package name and click on the little yellow light bulb, I'll click here on the show the most severe vulnerability. And look what patch did find here. Directory traversal, interesting. So this is introduced with this version that we're using here. It's fixed if we increase the version number, and we do have a proof of concept here. So what is happening? So the version prior to this version didn't properly prevent path traversal, and literal dots in a path were resolved out, but the URL encoding dots were not. So this is why we could perform this payload, and it leaks sensitive inf files and data from the server. Cool. So what is dietary traversal? If you're still asking yourself what is going on. So basically by manipulating the files with the // sequence or the variation, so using the URL encoding, it may be possible to access arbitrary files and directories stored on the file system, including open source code, configurations, and other critical system files. And this is what I've just demoed. And this note as information disclosure. So we have all of this information. Also, if you want to learn more about vulnerability, you can actually click on this if it's available, and it will redirect you to SneakLearn, if I can find it. Yeah. So SneakLearn is a free online platform where you can actually learn more about a few vulnerabilities. So if you select your ecosystem, and if I do directory traversal here, yeah, you have a lesson on directory traversal, just basically giving you more insights on it, and you can also try directly on the browser. It's sandboxed. So yeah, it's a good way to also learn about vulnerabilities, and it does keep progress. So you can create an account, a free account, and yeah, have a look at all these vulnerabilities. So going back to the IDE, so Patch said that there is, if I go back to package.json, yeah, this ST package can be fixed just by bumping up the version. So let's do this. Let me just close the server and do and install to make sure that changes are reflected. So here, basically, we're increasing the version of the package to hopefully remove the vulnerability. Let me just put back the server up. Cool. So if we're going back to the patch to-do list page, just gonna refresh it, and I'm gonna have a look at the payload that I've actually implemented this for the etc. And yeah, it's gone. I just had to refresh it, but yeah, it's gone. I cannot get access to that path anymore. So yeah, thanks patch for fixing the vulnerability. Yeah. Cool. And also, what you could do potentially is going back here and triggering another scan. So here, for example, you might see if I go to the ST package, if I find it. Yeah, here you can see that the vulnerability is still appearing here. But if you trigger a new scan, this should disappear because it's fixed now. It takes a few seconds to scan the project. And yeah, let's have a look. Let's go back to ST. And we should only have one, and we do have one. Yeah, so it's fixed. It's gone. Cool. Let's go back to this page, and let's have a look now at another vulnerability. Let's have a look at the store XSS, because you're seeing this is a to-do list. Yeah, so if we say like patch, yeah, you can see it's just to-do list. In that case, nothing fancy. But the important thing on this application is that we can use Markdown. So let's go back here. Yeah. So Markdown is basically a way to prettify your formatting. So you can use the headings, paragraph, links. So let's try with links. So let me try this. So if I right-click here, I should be redirected to Sneak website. Yes, so this is working. Okay. And also just to prove that it's using Markdown, we can use bold as well. So all good. So now I'm thinking, how can I tamper with this input? I'm just going to put the usual one with the script and the alerts. This is not working. Cool. Okay, so this is our sanitization in place, which is a good starting point. But I haven't said my last word, and I'm going to put back my attacker's hat and try to have an XSS payload here. So basically what I'm trying to do here is to keep the JavaScript colon protocol. Oh, I would say, sorry, I should start with that one. Yeah, so I'm trying with the JavaScript protocol in that case, and see if there is some sort of filtering. So just as a starting point, so in attacker will start with that kind of exploit and go from there and improve the payload. Oh, interesting. Okay, we do have the closing parenthesis in that case. So that's a kind of response in a sense. So yeah, what I was passing here is to do a variation of the JavaScript colon protocol. So here we're using HTML entities. So instead of having the colon, we're having the ampersand hash and 58, and instead of the closing parenthesis, we're having the ampersand hash 41. You can find actually all the you can find it here. Yeah, the complete list of your HTML entities, and what I was looking for is this one. Yeah, just going to zoom a little bit so you can see. Yeah, so the right parenthesis and the colon, or is it here? Yeah, you can see the colon. Cool. So this is what we're using here to try to tamper with this this input. Let's see if this is working. Oh, okay. It's completely gone. This is also some kind of response actually for an attacker. That's an interesting one. So we're using the JavaScript column to try to break out of the logic implemented potentially in the backend, and this is blocking us from hacking the application. And we're assuming that the condition must expect exactly the JavaScript colon protocol, and in that case, we're encoding it, and we're going to add another keyword, this keyword. So this is a valid keyword in JavaScript. You can also replace it with window or document. This would also pass. But in that case, the HTML entities and the browser permissiveness enable this vulnerability. So this bit here, this is not a valid HTML entity, but the browser will interpret this as a HTML entity, and then the markdown vulnerability allows it through the sanitizer. So let's have a look. Patch alert. Hey, we do have an alert here. So what we can conclude from here, so as an attacker, it gives you a way to perform an attack and break out of the logic that is preventing the JavaScript to be executed. And also for an attacker, that's the first step when testing an application to see if there's any entry point to craft a better payload. So you might say, Sonia, that's great, but it's just an alert box. This is not really dangerous. You're right, but this is actually an example of historic success. So if I do refresh the application, it's still here, as you can see. So the payload has been saved in the database. And if we think of this application as, for example, a social media application where you have user profiles, a visitor could potentially click on the link on the profile, and the data would be sent to the attacker's server containing sensitive information, for example, session cookie. So let's see what is going on in the code base to understand a little bit more what we have here. So let's go back to the app.js. Just going to close this. So as I mentioned, we're using Markdown in this application, and the package to enable this that we're using is called marked. So we're importing it here, and we're instantiating the package here. So you can see that we did a little bit of due diligence, because we do have the sanitize flag set to true. We had a look at the documentation, and we thought that it was secure, but it's not secure because we've actually bypassed the sanitization. So let's have a look at the package JSON, and let's ask the help of Patch for that. So I'm going to hover on the marked package, and again, click on this little light bulb and show the most severe vulnerability. And oh, interesting, we have cursor scripting. This is exactly what we're looking for. And again, you can also navigate to the snake-learn and learn more about this vulnerability. So what do we have? This is the package that we're using. This is the package version that we need to upgrade to fix this vulnerability. And we also have a little bit of overview on marked. So it's explaining that marked is a package used to enable Markdown, but also there's a few versions that are affected to and vulnerable to cross scripting. So an attacker could bypass the output sanitization. So this is what I've just showed you on the code protection using the HTML coded character set. And this is basically what I've performed on the application, and we had an alert. Cool. So here, this is called the cross scripting attack, and it occurs when the attacker tricks a legitimate web-based application or a site to accept a request as originating from a trusted source. Cool. And in our case, as I mentioned, this is a stored XSS. Cool. Let's fix that because we don't want that in our code base. So if I go back to the package.json and look at marked, I'll just bump the version here. I'll need to stop the server and do another npm install to make sure changes are reflected. So what you can see in those two examples, so we've actually wrote the code for. Whoop, yeah, I need to restart the server. Cool. And oh, you can see also that it's gone. But basically, what I wanted to say is we wrote the code for the this to-do list application, but we haven't implemented Markdown. We've used a package, and we haven't implemented how to serve static files. We've actually implemented through a package. And those two packages actually brought two vulnerabilities, or even more, within our code base. But let's go back to this vulnerability. I've refreshed the page, I've restarted the server, and you see that it's gone. This is where the payload was pushed. So let me try again one more time just to see if it's really gone. But yeah, I can't perform it anymore. So yay, we did fix another one. Thanks, patch. 2 vulnerabilities fixed. Amazing. Cool. So let's go back here and let's see what are the learnings. So yeah, we can use Sneak Advisor actually to check if a package is secure before implementing it into our code base. So let's have a look at that. So Sneak Advisor also is a free platform where you could potentially look at the health of the package before implementing into your code base. At the moment, we have npm, pypy, go, and Docker. So let's see with the st package. That's the first one that I've demoed. That's the first one. Cool. So we have a few information here on the side. We have several dimensions. We have the security one, popularity, maintenance, community. You also have this explore similar packages. So if you think that the health score is not enough, you can have a look at other alternatives and packages. Basically, this is giving you an overview of the security side. So if there's which version is free from vulnerabilities, but also it's giving you a bit more insight on the popularity of the package. It's giving you a bit of a timeline on when was the last release and last commit on the maintenance side, and also giving you a little bit more insight on the community, who are the maintainers, contributors, and other metadata. So that's a great tool if you want to check if a package is secure before bringing it into your code base and see if there's any alternatives. Another good way to test and have that visibility is using the snake tests within the CLI. So I've been using the IDE integration on through the Studio Code, but you can also use the Sneak CLI. So let me just showcase this. I'm just going to zoom here. So if I do Sneak test here, it'll go through. It will query the vulnerability database and come back with the all the vulnerabilities. So this is basically mirroring what you have here. If you think this is a bit too much info, you can filter using the threshold, severity threshold. This one, severity threshold equals high. So let me just do this. So severity thresholds equals high. And in that case, equals high. In that case, you'll only have a high and critical. So if you want to tackle those first, this is also a good starting point for your team. And yeah, in that case, you'll see it's all red, and you won't have the other vulnerabilities. So this also depends on how your workflow, what is your workflow within your team. And also a third, potentially a third option would be to have that visibility on the Sneak dashboard if you import your project, so you can monitor your project automatically. And if there's any new vulnerabilities introduced in your application, you'll be notified. So also potentially what you want to do this, so you would audit your dependencies. You want potentially to create SBOM, a software bill of materials, just to have the full inventory of your application. And this would help your organization understanding what their application relies on and identify vulnerabilities or license risk that may impact them. You might also want to fix vulnerabilities to monitor the vulnerabilities if there is any new one, and just to have your application to be continuously scanned. So just to showcase how it looks like. So here I've imported the Sneak Labs Node.js goof, and you can see here the package.json has been scanned, and you would have the same kind of information that you have on your ID with detailed path remediation, the overview, and from here you can actually click on this little green button to fix the vulnerability. You can open a fix PR on GitHub. You can cherry pick which one you want, or just bug fix everything. And you will raise a PR with all the information that you need to know to upgrade your packages. It will give you a little bit more info if it's this breaking changes, or if you feel like confident to merge it. Cool. As I also mentioned, there's a sneak learning if you want to learn more about cursor scripting or directory path and other vulnerabilities, not only for JavaScript ecosystem, but also for other ecosystems. Cool. Let's go back to our Iceberg, because we're always in two layers. So an application needs to be deployed somewhere. We're using containers and static website to deploy our projects. We have different ways to do so. We can use Docker, Traversal, Netlify, or any of the cloud providers. We could potentially add a Dockerfile, and now that's in the equation, we have more metadata about your project. So that's an additional layer for a modern application. We're running our application as Docker images, and this adds to the complexity in attack surface. So Sneak can help, Patch can help scan your Dockerfile and giving you that visibility that you need, the same as we've seen for the package.json. So let's have a look with a basic Dockerfile. I know I'm gonna say, Sonia, this is a really basic Dockerfile. I know, but let's see what could go wrong with this one. Well, a lot of things. Let's see them. So first, if we look at the run apt-get install -y image magic, they might potentially have vulnerabilities that we don't know in that specific package. That could be a point of attack. Also, when you do run npm install, there's also potentially vulnerable dependencies here. Might be better to run with the only production flag to avoid pulling dev dependencies and non-deterministic package during the install. Also, are we looking at the security release? What I do from nodes? If we're picking a large image, it might have many vulnerable libraries. So are looking at those security built-ins to have that visibility. So when you import your project, you will have recommendation on upgrading the base image. So you can see here for this Dockerfile, the current image that we've been using is, in that case, the node 10.4.0. But you can see this alternative upgrade. So if you move to the node 16 or node 18, it's completely free from criticals and high. In that sense, potentially we could recommend to have a multi-stage Docker build. So during development, you can use a larger image to experiment, but when you move to production, use a slimmer image, which are free from vulnerabilities. And also, you can use the Sneak Advisor to give you also that kind of insights and visibility, and help you taking decision on which Docker image will suit your project. So going back to the Sneak Advisor, so if you click here on the dropdown, you just need to change here to Docker. And for example, if I do node, I'll just click here, and it will give you all of the insights here. So the number of stars, the number of downloads, and like the latest tags. But if you're using a specific tag, you can select it here and compare against it. Cool. Also, we did produce a cheat sheet for the Docker image security best practices, where we do recommend to prefer minimal-based images and use multi-stage builds for small secure images and other good tips. So yeah, just go and have a look at this one. Before moving to the next layer, I'm going to try to exploit a Docker container. So I'll just prep for that one. Cool. So as you can see, this is a really simple Dockerfile, and you might think, yeah, that's cool. What will be the payload for this one? So in this container, I'm going to set the context first. We're using a package called Image Magic. The thing is, with this package, the team actually created dedicated website to explain what was going on with Image Magic, because that package had a lot of vulnerabilities, and they've called it imagetragic.com just to explain what was going on. So it's a package commonly used by web services to process images. So if you want to resize images, this kind of package that you would potentially use. one of the vulnerabilities can lead to remote code execution. This is what I'm going to perform here, where the user, the process user submitted image, just not great. So I already know what is going on. So let me just build the Docker container. Just make sure I'm doing no caches to make sure that previous installations are going to overwrite. Might take a few seconds. Cool, and I'm going to create. I'm going to run the image after that. So, npm install is always the bit is taking a long time to install. That's a lot of dependencies. Cool. Okay. So I'm going to run the Docker image, and I'm going to navigate to. Yeah, cool. Just going to close this one for. Close this. Yeah, this would be better for everyone. Cool. So I'm navigating to this really fancy application, as you can see. Yeah. So the goal here is to upload an image to convert it to Twitter ideal photo size. So the first exploit that I'm going to import is this one. I'm just going to close this. Yeah. So it's this one, rc.jpg. So if you have a look at it, it's using the ImageMagick API, and what we're doing is creating a file here after the pipe touch RC. But before that, I'll need to set up the scene as an attacker. So let me just split my screen. So just going to create one. Split. Split. Cool. Okay. So first of all, on this one, this screen will be the one where I will spin the local static server to serve the netcat package. So I'm just going to minimize this one after because we don't really need that one. This one will be where we connect to the Docker container. So in this one, you can see if I do who I am, I'm root, and if I list the files, you can see that here at the moment we don't see the RC1 JPEG. Cool. Can I clear this one? Yeah, just to make sure. Okay, and this one will be for the second exploit, but I'm just going to run the netcat to make sure I don't forget about it. Cool. So now that I've set the scene as a hacker, let me just import the first exploit. So if I go to, I need to find the file now, exploits, and the first one. So that's the one that I've showed to just to create the file rc1 JPEG resize. Cool. So image resizing success. We don't have an image, but let's have a look at what is going on here on our container. Here, we do have a new file that has been written on the Docker container. Cool. So you might say, yeah, cool, Sonia, but this is just creating a file on the Docker container. It's nothing really fancy. Well, I would say let's move to the other exploit, the one where actually we're gonna create a remote code execution. So instead of having like the first one, I've just created a touch RC1, I'll have a proper reverse shell here in that case. Cool. So I'm just going to put here who am I, just to make, probably after. Cool. So going back to the page here, and I'm going to import. So the second file, this is the one with the exploit. I'm going to resize that. And oh, look what's going on here. This is hanging, which is not great usually when the request doesn't terminate. So let's have a look here. Just going to put here in mind just to make sure that it should come back as root on my side. But what is going on? So we'll have to wait 10 seconds for the netcat utility to be downloaded from the local static file server. It has to be compiled and executed to then create a reverse shell that allows us to interact with the local netcat listening prompt. So if we have a look here, we should start seeing things written. Yeah, you can see here the magic dash da 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 da. This is a great sign, and you can see here the reverse shell has been created here. So we should have the response coming back here, hopefully. Should, because something is going on the second screen, so we should have the roots back. Come on. So basically what is going on here, so by using the image, oh, here, we're back root. So yeah, just finish on that. By using this image magic package, and because of that vulnerability, we can actually perform RC on that. So let me try, do they have Python here? Yes, can I copy, just gonna try to change the shell, because this shell is not pretty. It's just like spawn, and then I'm gonna bin bash this, hopefully. Yes, this is a bit more pretty. So who am I? I'm root, great. Where I am, cool. So yeah, you can imagine, like, if you navigate through and you can start exfiltrate data, you can see, like, yeah, I can go to the root folder. In this application, we didn't have much on that. It's just to demonstrate that you could perform RC with that vulnerable package, and then the hacker have access to your Docker container and can navigate and exfiltrate sensitive data. So potentially, if you had a database or those kind of sensitive info, credentials, anything, yeah. Thank you, image magic. Cool. Let's going back here, and let's have a look at the last layer. So we had the application code. This was the tip of the iceberg. Then we moved down layer with the open source code. Then we had a look at the containers, and the last layer. What could that be? So this is infrastructure as code for the last layer. And IIC is an approach to manage data center servers, storage, and networking infrastructure. It's meant to simplify large-scale configuration management. So you're provisioning your resources through code instead of manual processes to make sure that your application is scalable and available. You can make your code as your single source of truth, in that case, where you specify explicitly through code all the infrastructure specification in your config file. You can have version control on all of your config files. You can test and monitor your configuration. Infrastructure as code is amazing. But the most common vulnerability organization face is cloud misconfiguration. And this refers to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. So you have a few numbers at the bottom. So 77 million PlayStation Network accounts hacked, in that case because of misconfiguration. For Uber, it was 57 million customer and driver info breach. Basically what happened here, they had a public GitHub repo where they actually store AWS creds. And also for FedEx, 119,000 scanned documentations in FedEx breach, just to give you a few examples on what could happen with cloud misconfiguration. Cool. So let's have a look at a third application. This one is down, but with the RC is down. Cool. I'm just going to close this one and close this. Cool. Yeah. So what we have here is, again, a basic Terraform file, but just to demonstrate how you could use the Snyk IAC in that case. So you can see a few Terraform files here. We're using AWS as the provider. The one that we're going to be interested in is this AWS IAM account policy, password policy strict. There's a few rules here that are committed out. We do have other modules to have VPC, storage, and CloudTrail information, but we're going to focus on this one. Cool. So if we run now the Snyk IAC test, it'll come back with a few errors, or issues, I say a better word. Yeah, we have the test summary here. So this is the one that I've scanned. And you will see the total number of issues. In our case, we have 3 highs, 9 medium, and 7 low. So if we have a look, it gives you a little bit more idea on the rules, where there's some issues. So for example, on the S3 bucket, on CloudTrail, credential security groups, The one that we're interested in is the IAM password. So you can see here, IAM password should contain symbols, should contain lowercase, should contain uppercase. Okay, cool. So let's fix that. So I'm just going to remove this here, here, here. Cool. And I'm going to rerun the sneak IC test. And it should come back with less. Yeah, so we went from 9 medium to 5 medium in our case. So you can see you have like direct feedback on that when you scan with IIC. Also, the good thing, if you ignore the rules, you don't know and you want a bit more context, what you could do is potentially click on one of these rules. So if I go back here, and you have like those URLs. So if you click on one of them, it will redirect you to our sneak security rules, where it gives you a little bit more context with what is the issue. So in that case, this is for the IAM service. The password should contain uppercase, so your password doesn't contain uppercase characters, the impact, and how you would resolve this. Yeah. So you have other rules around IAM. Discuss this few rules, but also it's not only about IAM. There's a lot of different AWS services that you might be using. And also, it's not only about AWS, you also have Azure, GCP, and Kubernetes. So we do have those set of rules. And we're checking against the CIS benchmark. So it's basically, CIS stands for Center for Internet Security. And benchmark is giving you a few guidelines or how you would secure and harden your infrastructure, which is a strong starting point for hardening your infrastructure. Cool. So let's go back to the modern applications. And now that we've seen all the layers of the Iceberg, we have a global understanding of every layer and what is going on with this application. So we know that 10 of 20% or 20% of our code base is proprietary code, the code that we write in a company. This potentially might have security issues, but also we're bringing more vulnerabilities if we add open source libraries, which result from 80 to 90% of your code base. But also when we containerize our application, we bring the Unix packages. We bring also vulnerabilities potentially with the base image that we're using. And finally, the last layer with the ISC, and one of the security risk could be misconfiguration in that case. So we need to be aware of all of these different layers and potentially the vulnerabilities that we're bringing within our project. So it is important to have guardrails at each stages of our pipeline to spot the vulnerabilities as your attack surface is getting bigger. So demonstrate a few entry points here with coding. So with the ID integration, with the sneak CLI, but also with the sneak test for IAC. You can also have that with the repo when you raise a PR and you have sneak scanning your PR and let you know if there's any vulnerabilities. You can also implement it within your CI/CD pipeline. So should you use GitHub pipelines, GitLab's pipelines, or Azure pipelines, or any others like Jenkins, Circle CI, depending on your implementation and your workflow, you might have those endpoints where you could potentially put security guardrails at these stages. And we want to have this DevSecOps feedback loop. It's important to empower developers to build applications securely within the entire development process. We don't want to have siloed teams. We don't want to have like the engineering and security teams to be siloed. We want them to work hand in hand and to have better understanding and visibility and what's going on through their pipeline. Cool. So let's see a few practices to implement defense in depth. So let's start with the OSS layer. So we would recommend to inventory your open source components because we don't want to give hackers more tools to expand their exploits. Leverage security tools. This would improve your OSS security posture by having those security tools implemented within your pipeline, and embrace automation because obviously we want to eliminate manual activities. Yeah. Also, include your OSS components in use within your security policy if you have one. And also the SBOM, software bill of materials, that could help identify a software package for content and license data. So let me just showcase the SBOM. Which one I can use for that, because I've closed all of them. Let me just open another. Hopefully this works. So what basically I'm doing is I'm going to scan this this repo with the sneak test. I'm going to use the JSON formats and the sneak2 SPDX package, just using JQ for querying. Yeah, and obviously it fails because this is not the correct one. Let me just reopen one of. So this is the Node.js goof. Let me try with this one if it works. Yeah, okay. So I'm trying with the Node.js, the first one, goof application, and this will actually populate your SBOM. So if you're using a tool that aggregates all of your SBOM, you can potentially have that kind of information here. So it's giving you all the goodies. Cool. The continuous layer, don't run as root. You probably don't need it. Also, avoid using privileged containers. Drop capabilities and allow only the one you need. Read only root file system. Immutability makes exploiting your containers harder. And also deploying for known sources, but also pull from known registries only. Cool. And for ISC secrets, use them, but make sure that they're encrypted and have role-based access control applied. Hopefully everybody is using this one. Security context for enforcing not running as root. Having also a network policy and enforce all of them using an open policy agent like a Gatekeeper to have policy controller for Kubernetes. You can use also Kyverno, which is a policy engine designed for Kubernetes. You have a lot of tools from the Cloud Native Computing Foundation on that to enforce and harden your projects. Cool. So I'd like to finish with 3 top tips. And that's the first one. Adopt a DevSecOps approach or the shift left approach. Obviously, all the approach like right, left are important. But if we focus on the shift left approach, it aims to detect security holes from day one in order to prevent security issues to begin with and to resolve them as quickly as possible if they do indeed arise. And DevSecOps enable development teams to spot security issues at all stages of the software supply chain, from design to implementation, but it's important to catch them as quickly as possible. Second, address open source vulnerabilities. We all love the open source ecosystem, and offers a great number of benefits, including cost efficiency. They also expose us to significant vulnerabilities. We've seen a few today. So when using open source components, make sure to have ongoing monitoring for vulnerabilities and to address, to regularly update and patch vulnerabilities as quickly as possible, because this is therefore critical. And lastly, security training for developers, because developers are also responsible for pushing code into production, and it's critical for them to have a good understanding of what is going on within the security realm. And obviously, this training should be tailored to the specific developer's role and security needs. That's a good starting point for developers to understand a bit more what is going on and having those tools integrated in their pipeline. So let me present a few useful resources. This is a nice segue actually for that. So the first one is the Sneak security resources. So we do have a few cheat sheets covering NPM, React, Docker, and Log4Shell, and many, many others. So this is a really great resource that we have. Sneaklearn, also, I really like that one because, as I said, obviously it keeps progress, so you can start a lesson, continue a little bit after. But it gives you a lot of vulnerabilities that you can play with, have a better understanding, and yeah, it covers a lot of ecosystem. It's not only for JavaScript, they have also Java, PHP, and others. The State of Open Source Security 2022, this is the joint effort between the Linux Foundation Research and SNCC, which showcases the current state of open source software security and gives you methods to address and improve security postures. Really great metrics and insights on the open source software ecosystem in that report. And lastly, this is the one that we released 2-3 weeks ago, the State of Cloud Security Report 2022. And this report on the cloud risk and security challenges organization are experiences this year. So also really great reads and give you a lot of useful insights. I'm Sonny Moiset. I'm a senior security advocate at SNCC. I'm passionate about DevSecOps, open source, and cloud security. I'm doing a lot of things outside of SNCC. I'm not going to bother you with that, but you can reach out to me with Sonny Moiset on LinkedIn or Twitter. Yeah. And I'd like to thank you for attending today's session. I hope you learned a few things. And yeah, I'd like to say stay safe in your journey to cloud native application security with Patch as well. Thanks, Patch, for today. Thank you.
Thanks, Patch. Thanks, Sonia.
There's...
But mainly Patch. No, just kidding.
Yes. Cool. Thank you, everyone, for attending. Bye.